Morning Year 12 Further Mathematicians. Just going to teach you about the reverse chain rule 11.4 today. Now, clues in the name, chain rule, but we're going to do it in reverse. So I need to remind you of two different properties or two different rules inside the chain rule. First one. If I asked you to differentiate ln f of x, for example, so ln of some function, to find dy by dx, what would you do? Well, you should know that ln goes to 1 over, but the chain rule also says you have to times by that function differentiated. That function could be something like 3x plus 5, it could be some trig stuff, it could be anything, but whatever it is, you times by it differentiated. Now, what's the best way to write that? Well, that would be f dashed of x, f of x. Now, what we're going to be doing today is doing this, but in reverse. So you're actually going to be given functions which look like this, and you have to guess these. So if you have to integrate something like f dashed of x, f of x, like that, with respect to x, you're going to have to guess y is equal to ln f of x. Okay, the denominator. Now, you're not going to get this perfect. It's going to be a multiple, so I'm going to write k for a multiple. But that's what your guess would be. If you see function on the bottom and its derivative on the top, you're going to guess y is equal to ln f of x today. That's one thing you have to do. The second one is y is equal to f of x, but to the power of something. What would this differentiate to? Well, chain rule says something to the power of n, bring the power down, subtract 1 from the power, but you have to multiply by that thing differentiated, so times in by f dashed of x. Some people write that as n f dashed of x, f of x to the power of n minus 1. And again, today, I'm going to be asking you to differentiate this, integrate this, and go in the opposite direction. So you have to spot stuff like f dashed of x and an f of x to the power of something. I'll just put a power of n there, dx. And then your guess for this is going to be y is equal to, add 1 to this power, f of x to the power of n plus 1. And again, you're not going to get this perfect. They're going to give you multiples of it, so you still have to guess the same thing. Okay, so let's try and do this actually with some functions now rather than just talking about f of x's. E.g. number 1. Can you spot either f dashed of x over f of x or f dashed of x times a power of f of x? Now this one, x squared plus 1, what does that differentiate to? 2x. Well, that looks promising. So my guess would be ln of the denominator, ln of f of x, because I'm spotting this pattern, integrating f dashed of x over f of x. See how bad the guess was? dy by dx. Okay, what does ln differentiate to? 1 over. But remember to times by the bracket differentiated. That's the chain rule. Times by 2x, which is 2x over x squared plus 1 And finally, this is actually the perfect answer. So this integral, which I'll call I for integral, is equal to my guess plus C. That would be it. So you've got to spot that. You've got to spot that the top is the bottom differentiated. Gives you a bit of an idea then on what to guess. Right, next one. E.g. number 2. Right, so this one's probably a little bit easier to guess based on this being something to the power of 3 and then x on the outside. So for me, this is similar to this rule. Spotting this pattern, f dashed of x, because what does 2x squared plus 5 differentiate to? 2x, not quite 2x, but it's an x. And then you got something to a power. So remember what the guess said. It said add 1 to the power. X squared plus 5 to the power of 4. See how bad this guess is. dy by dx. How do you differentiate this? Well, something to the power of 4, bring the power down. Subtract 1 from the power. And the chain rule says times by that bracket differentiated, so times in by 2x in this case. Which would simplify to 8x brackets x squared plus 5 all to the power of 3. Now, how bad was that guess? It was out by a factor of 8. So I'm going to call that I for integral. Out by a factor of 8, so I'm going to divide by 8. So 1/8 of my guess. Plus C. And that would be it. Again, you've got to spot that pattern. Right. E.g. number 3. Getting harder. We have cos x over 3 plus 2 sine x, that integrated. Which of the two patterns do you think this one looks like? Probably the fraction one, so f dashed of x over f of x. Let's just see if this does make sense. Well, what does that differentiate to? Well, that disappears, and sine does go to cos, so it could work. So let's guess ln of the denominator. dy by dx. Ln goes to 1 over. But you've got to times by that something differentiated. What does 3 plus 2 sine x differentiate to? 2 cos x, which is 2 cos x over 3 plus 2 sine x. How bad does that guess? Well, it was out by a factor of 2. 2 times too much. So the integral, which I'll call I, needs to be half of my guess. Plus C. Now this is a double lesson, so this is the first half. I'm going to do some more examples in the next video. But the questions I'd like you to try right now are on page 303, exercise 11D, and you're going to try question 1, second column. Try question 2, second column as well. Any problems with any of these, then post a question on the chat.